All right, we are on Geometry, Chapter 6, Lesson 6-1. And print, it's on page 228. It's titled Medians. And in Braille, we're actually starting on 228A. And it should start in a triangle, a median. So this section is about learning how to identify and construct medians and triangles and their definition and what that means in relationship to figuring out the measurements of distances of segments of sides and segments of a median in relationship to the centroid and a theorem that deals with that relationship in centroids. So the very first thing that we do in this chapter is look at three drawings that discuss the definition of a median. And a median is a segment that joins a vertex of a triangle and the midpoint of the side opposite that vertex. So you have a triangle on this first page, triangle ABC. A is the top left corner, B is the top right, and C is the bottom left. And from vertex B at the right, there is a dotted line that goes through approximately the middle of the triangle and connects with the side opposite at a point labeled D. And that point D is the midpoint of the side opposite AC. And notice that there is a tick mark from A to D and a tick mark from D to C, showing congruency, that AD equals DC. You learned quite a while ago, several chapters ago, about midpoints, a very kind of basic definition. It should make sense. A midpoint means in the middle, therefore it's dividing something exactly in half, so both sides of a segment that divides in half would be congruent to each other. So if this side AC was 10, then from A to D is 5, and from D to C is 5. And now you have a new definition of a median, that is a segment that comes from a vertex to the side opposite the vertex at the midpoint. And by definition of a median, then you know if you're told that BD on this particular triangle is the median, then you know by definition of a median that the D point is the midpoint of AC, and then therefore you know the relationship between the two segments AD and DC that make up AC. They are equivalent, or their AC is exactly in half. All right? Down below your drawing, it just says in bold, median line segment BD. The next drawing on the next Braille page in print, it's immediately to the right. We have a triangle RST. R is the bottom left vertex, S is the top vertex, T is the right vertex. From the vertex T is a dotted line going through the midst of the triangle. That is your median. It's going to the point U. By definition of a median, it goes from the vertex to the side opposite the vertex to its midpoint. So therefore you know that S to U and U to R are equivalent, and they each have a tick mark showing that equivalency. But by definition of median later, you don't need those congruency marks. You just know that SU equals UR. Okay? And then below the drawing, it also then says median line segment TU. The next drawing, immediately to the right in print, one page over in Braille, you have XYZ, triangle XYZ. X is the top left vertex, Y is the top right, Z is at the bottom. From vertex Z up through the triangle to point W, ZW is a median. It's showing that point at W is the midpoint because from X to W has a tick mark and from W to Y has a tick mark showing congruency. So those were three examples from three different vertices showing medians and that they connect with the side opposite and at the midpoint. The next several pages and drawings are constructions of a midpoint using a compass and a straight edge. We're going to do constructions later this year in one whole unit where we go through several constructions. So we're going to bypass this information and we're going to make our way to page 229 in print and 229 in Braille. So this is an example where we're going to use the information that you know about medians to solve problems. And it'll be very simple at first, but then they're going to put algebra to it. Of course, they're going to put algebra to it. And that's going to be more like what you're going to see on the end of course exam. This particular example up at the top says, example 1, in triangle EFG, EN is a median. So you need to kick on your brain and go, all right, they're telling me about a triangle. They're telling me about a median. What do I know about medians? I know medians go from a vertex to the side opposite at the midpoint. I know it's going to divide that side opposite into 2 equal segments. That should just be automatic what you're thinking about medians and midpoints. So we have a triangle. You go take a look at it. You have E at the bottom left, F at the top, and G at the bottom right. From vertex F, it goes straight down to point N, and you're given that line segment FN is a median. So you know where it connects at N, that's a midpoint. So your brain kicks in and knows N is going to divide that side opposite exactly in half. Therefore, EN is going to equal NG. If you're told, it says up at the top, find EN if EG is 11. So you go back and look at your drawing and go, okay, I need to find E to N. I need to find half of my segment. I'm given EG is 11. So your brain kicks in, you got to find half. Half of $11 is $5.50 or 5.5. 5 1/2 as a fraction. So it's pretty simple math. It tells you how to find that down below the drawing. It says FN is a median, so N is the midpoint of EG. Since EG is 11, EN is half of 11 or 5.5. Turn the Braille page. Our print users go one example down into the Your Turn. Now it says in triangle MNP, MC and ND are medians. So we got 2 medians going on in this triangle. We need to decipher those, and then we need to find some information about them. So very carefully work through your tactile, work through your drawing. Triangle MNP. So M as in Mary is top left. N as in Nancy is bottom left, and P is top right, MNP. So there's the full triangle. You have a median according to the givens, MC. So at vertex M, notice it always starts with median. It starts with the vertex point, M to C, and that's your midpoint of your side opposite. You also have a median ND. So you find your vertex at the bottom left and go up to D through the triangle, and that's another median. So you know D is the midpoint of NP. So you have a couple of things going on here that you can decipher. You can say, hey, if they give me the measurement of NP, I can figure out MD and DP. Or vice versa, if they give me the measurement of MD or DP, I can figure out the measurement of the other or the measurement of the whole side. Likewise, the side opposite your vertex M is that long side NP. And so you know that MP is divided by C, the midpoint. So NC is congruent to CP. If you're given NC or CP, you can figure out the entire segment or the other measurement. So you're just kind of kicking that in and thinking about that and predicting what they might ask you. Then you go down below the triangle, and little letter A asks you the question, what is NC if NP is 18? So you go find NC and NP, and you go, aha, NC is part of the entire side MP. And I know by the definition of median and midpoint that C is the midpoint. They gave me NC, or they didn't give me, they said, what is NC? They gave me the whole thing, NP is 18. So you go, aha, I got to divide by 2. NC is 9. In little letter B, it asks down below, little letter B, if DP is 7.5, find MP. So you go up and you find DP. You notice that D is your midpoint of your side MP, and they're giving you from D to P is 7.5. You know by definition of median and midpoint that that's half of your entire segment, so you got to double it, and you know that 7.5 times 2, then your entire segment is 15. So very basic math that you just have to be very careful with deciphering What are they asking you? Are they asking you for half of the segment, or are they asking you for the whole segment? Or vice versa, are they giving you the whole segment and you have to find half of it, or are they giving you half of the segment and you have to find all of it? Now, it's probably not going to be that simple on the end of course exam. It's going to be more like the next example with an algebra link. So turn the Braille page to 229B. And print users, we're looking at example 2. I'm going to really take time explaining this drawing to you, explaining the process, and then the next page we'll go through the proof of it. Again, we want to think proof-wise because you're also going to need to write proofs on the end of course exam. Plus, it's just a good way of realizing what's going on. So first they give you the givens in example 2. You always want to read your givens very carefully. So it says, in triangle RST, RP and SQ are medians. So your brain hopefully kicked in. Medians mean they go from a vertex to a side opposite at the midpoint. I'm going to have something going on with things equal to each other or half of each other or double of each other. It says if RQ is 7x minus 1, SP is 5x minus 4, and QT is 6x plus 9, find PT. So now your brain kicks in and goes, I'm going to be doing some algebra. Got to be thinking smart. But let's not try to figure this out till I look at the drawing. So triangle RST is down below. R is the bottom left, S is the top, T is the bottom right. If you go back up and read your givens, you're told that RP and SQ are medians. So go find your vertex R, follow the line through the midst of the triangle to P. So you know that you have a median from R to P. You know then that P splits up side ST. Therefore, your brain should kick in and you should say, hey, SP is going to equal PT. That's important. Then you go back up to the givens and it says SQ is a median. So you find vertex S and you go immediately down to the Q point at the side opposite, and you know that's a median, and you know Q is the midpoint, so you know that it's dividing up that side opposite RT into two congruent segments. RQ equals QT. Kick that in. Think about it. Now you go back up and read all the algebra. They give you RQ is 7x minus 1. So you go, okay, from R to Q is 7x minus 1. They give you SP is 5x minus 4. So, okay, on the right-hand side, SP, that little portion of my side, is 5x minus 4. So far, I can't do anything with that information because SP does not equal RQ. Then you go read that QT is 6x plus 9. Aha! I have two of my segments on RT. I have RQ is 7x minus 1 and QT is 6x plus 9. I know by definition of midpoint those two segments have to equal each other. They're congruent. So I'm going to make those two expressions equal each other and solve for x. So that's where you just kick in your algebra, and it's very basic algebra. You would have 7x minus 1 equals 6x plus 9. Solve for x. Now, once you get x, you're not done. Don't mark the little letter on the end of course exam that gives you the value of x. Many students will do that because they had to do a lot of work to get there, but that's not what they asked you for. They asked you for what the measurement of PT is. Well, now that you have a value of x, you go back to your givens and you're told SP is 5x minus 4. So you go, okay, well, SP is going to equal PT, so all I got to do is plug in my value of x, solve for SP, and then I know what the value of PT is. So you plug in 10, 5 times 10 minus 4, and you get the answer of 46. Down below the drawing in print and on the next page in Braille is the proof of what we just did. For the most part, I'm a little more specific in that I like you to use a few more mathy words, but we'll go through this proof. So the very first line says RQ equals QT on our drawing, and we're able to state that by the definition of a median. We know a median comes from the vertex to the side opposite at the midpoint. So we know that it divides that side into two equal segments. So that's why they're able to say segment RQ equals QT. Definition of a median. Then we plug in what they gave us about RQ and QT. 7x minus 1 equals 6x plus 9. That's the substitution property. Then we add 1 to both sides. We have 7x minus 1 plus 1 in order to cancel out that 1 equals 6x not plus 9 plus 1, because whatever we do to one side, we got to do the other. It says down below, add 1 to each side. Right here, it would be more appropriate to say addition property of equality. Then they do some simplification. 7x equals 6x plus 10. They just say simplify. And then you got to get all your x's to one side. So 7x minus 6x equals 6x plus 10 minus 6x. They choose to cancel the x's on the right so we don't end up with a negative. They simplify again. Now that's subtracting 6x from both sides. That's the subtraction property of equality. And then we get x equals 10 when we simplify. Then we use that value and we plug it in and we prove why we can do that. SP equals PT by definition of a median. We plug in 5x minus 4 for SP equals PT by the substitution property. We replace replace x with 10. That's also the substitution property. 5 times 10 minus 4 equals PT. We do some simplifying and 46 equals PT. So that's the proof. That's a proof format of every step. That's the kind of stuff you'll have to show on the EOC a couple of times. Very simple definitions or properties used, but we're writing out why we can do each step. All right, turn the Braille page, turn the print page to page 230. Now we're going to talk about a couple of interesting definitions in regards to medians of triangles. And when you have all the medians plotted on your triangle, they intersect at a point in the midst of the triangle that's called the centroid. And whenever 3 or more lines intersect, they're called concurrent lines. That's another definition. But the biggest one you need to remember is the centroid point. Where they intersect in the midst of your triangle is called the centroid. If you take a look at the drawing, we have triangle JKM. J is the left vertex, K is the top right, M is the bottom vertex. They have a median coming from each vertex. From the left J vertex, there's a median going through the midst of the triangle to point R, the midpoint of the side opposite J, MK. From the top right vertex K, we have a median going through the midst of the triangle to point P on the side opposite. And then from the vertex M at the bottom, we go up through our triangle through the midpoint Q of the side opposite. Where all 3 of those medians intersect, there's a point in the midst of the triangle called the centroid, and that is labeled point X. Now, there is a relationship, a special relationship between the first part of our centroid and the last part of our centroid. The first part meaning coming from the vertex to the centroid, and then from the centroid to the midpoint. There is a special relationship. You can almost sort of see it or feel it, but they prove it with the next 3 drawings. They have us deduce, come up with a conjecture, our next theorem as to what that relationship is. So on the next Braille page, 230A, you have a drawing, you have a triangle ABC with 3 centroids coming from each vertex. A is top left, C is top right, B is bottom right. There is a median coming from A to midpoint D, a median coming from vertex B to the side opposite at midpoint E, and a median coming from vertex C to the side opposite at midpoint F. These medians are all intersecting in the midst of our triangle at point X. They are giving us the measurement of A to X and X to D. So the median of AD, they're giving us the measurement. AX is 26 and XD is 13. Turn your math brain on and notice that relationship. Hopefully immediately you noticed that 13 is half of 26, or 26 is double 13. The next 2 drawings show the other medians and their relationship. The drawings get a little bit bigger, but just ignore the size. We have triangle ABC again with 3 medians going through the midst of our triangle and at a centroid point X. They're showing us the measurement of the median BE, the bottom right vertex to the midpoint E at the side opposite. From B to X, the centroid, they're telling us that's 20. And from X to E, the drawing is saying it's 10. Notice the relationship. From X to E is half of from B to X, or B to X is double from X to E. Same as the last drawing. So the final drawing showing the third median, to make sure we've proved all of these to be the same so we can make a deduction, we can make a conjecture. We have triangle ABC again. A is top left, B is bottom right, C is top right. We have medians from vertex A, B, and C. Now take a look at vertex C and its median going through point F at the side opposite, the midpoint. We go through a centroid at centroid X. From C to the centroid X is 18, and from the centroid X to the midpoint is 9. Again, that relationship is a 2-to-1 relationship. C to X is double from X to F, or it's F to X to F is half of C to X. Okay, so that leads us to our conjecture, or our theorem, for the next page on 230D, and we're in the blue box in print of theorem 6-1. The length of a segment from the vertex to the centroid is twice the length of the segment from the centroid to the midpoint. So notice on this triangle, this big picture, they don't label them, they just show medians from each vertex. And from the very top vertex to the bottom midpoint, they're showing that from the top vertex to the centroid point, they're labeling it 2x to the right, and from the centroid to the midpoint, they're labeling it x. So from vertex to centroid is double that from centroid to midpoint. Now, put your brain on and think about what the entire length of your median is. If from the vertex to the centroid is 2x, and from the centroid to the midpoint is x, we're going to combine like terms, 2x plus x, and our entire median is 3x. And that's important to remember because sometimes they're going to give you the length of the median. You got to divide it by 3, and then you can figure out your short part of your centroid, and then you can double that and figure out your long part from the vertex to the centroid. Okay? All right, turn the page, and we have examples. So example 3, it gives us some givens at the top. In triangle XYZ, XP, ZN, and YM are medians. Brain kicks on. You are geometrists. You know what a median is now. You know what things, how it defines things. It's going to hit a midpoint, divide things in two. It's also going to crisscross each other. And at a centroid, there's rules now, a theorem about the centroid and the relationship of the length of the median and the space from the vertex to the centroid and the centroid to the midpoint. It's a 2-to-1 relationship. So we have triangle XYZ that we're looking at. X is to the left, it's the left vertex. Y is at the top, Z is at the bottom right. From vertex X, we go through the midst of our triangle to midpoint P on the side opposite. From vertex Y at the top of our triangle, we go down through the midst of our triangle to midpoint M of the side opposite XZ. And from our vertex Z at the bottom right, we go up through our triangle through the midpoint N at the side opposite. Where all those centroids cross, they're concurrent, they cross, they intersect at a centroid point Q in the midst of our triangle. We know the relationship of all those medians if we're given any of the measurements. So of course they're going to give us those. They're going to say up at the top, find ZQ if QN is 5. So we go back and we find Z at the bottom right, and we go to Q, and we want to find ZQ, and it's telling us QN is 5. So we know the relationship is 2-to-1. So if QN is 5, we double that, and ZQ is 10, right? And then if we add them all together, that's 15, or 3 times our X value, right? 3 times 5 is 15. That's important to remember because the next question asks, if XP is 10.5, what is QP? So we find vertex X at the left. We go immediately to the right through P. We have the entire median that they're telling us is 10.5, and they want to know what QP is. You have to remember that your entire median is always 3x. You divide your median by 3, and then you can multiply it by 2 to get the first part of the median, and then the leftovers, 1x, is the last part. So 10.5, 3x equals 10.5. Divide by 3 on both sides. 10.5 divided by 3, x equals 3.5. So you know QP is 3.5. Then you also know that XQ would be the leftovers, or 2 times 3.5, which would be 7. If you add 7 and 3.5 together, you get 10.5. So we did it right. Okay. Then it says down in your turn, actually in the next page, sorry, your turn, it gives you another triangle to look at. It says in triangle ABC, CD, BF, and AE are medians. So we want to go take a look at our triangle. We have ABC. A is the bottom left vertex, B is the top left, and C is the bottom right. And we connect all those and we have the outside of our triangle. From vertex A in the bottom left, we go through the midst of our triangle to the side opposite at point E, midpoint E. We go to vertex B at the top left, and we go through the midst of our triangle to the side opposite to point F, midpoint F of side AC. And then we find vertex C in the bottom right, and we go through the midst of our triangle, and we go through it to the side opposite through point D, midpoint D of segment AB. Notice they intersect in the middle. That's our centroid point, and they've labeled that above it as G. We know now from deducing it ourselves and from theorem 6-1 the relationship of all the parts of our medians to each other. From the vertex to the centroid is always double from the centroid to the midpoint. So if they give us any of that information, we can find out the measurements of the other part. So they're going to do that. It says down at the bottom in little letter C, if CG equals 14, what is DG? So we go to C, we go C to G. G is my centroid, and they're telling me that that is 14. So what is DG or GD? What's the little one? Well, if I know that CG is 14, I know that's double GD. So I'm going to half that. CG 14 divided by 2. GD needs to be 7. Right? If they pushed us farther and said, what's the entire length? We just add those together. 14 and 7 is 21. If we divide by 3, we get 7 again, right? And then 7 times 2 is 14. It all works. The next question, little letter D, asks, find the measure of BF if GF is 6.8. So we go up to find B, and they go all the way to F. So they want to know the entire median, BF, if GF is 6.8. So there's a couple ways we can do this. We know GF is 6.8. Then we know BG has to be double that. So that would be 13.6. Then we could add 13.6 and 6.8 and get 20.4. Or we could remember that from B to F is 3x, 3 times the value of x. And we know GF is always the x value. Well, if GF is 6.8, 3 times 6.8 is going to be 20.4. 3 times 6 is 18. 3 times 8 is $2.40. 18 plus $2.40 is $20.40, 20.4. So a couple ways of going about those measurements, right? So that's medians of triangles, centroids of triangles, and their relationship from vertex to centroid and centroid to midpoint as far as their measurements are concerned. Now you're able to do the rest of the homework, the check your understanding on page 231. You should be able to do all of them, numbers 1 through 29 if you needed to. It's good practice to at least do 1 through 7. Number 2 asks you to draw a figure that shows 3 congruent segments. You could explain that. That just means that 3 lines are intersecting. But you should at least be able to do 1 through 7, and for extra practice, could do the remaining of the problems. Number 26 is the famous rowing machine problem that has a funny first sentence, if you'd like to take a look at that and read that. All right, everyone, that's the end of 6-1. Happy studying and practicing. We'll see you in 6-2.